Hi, in section 3.5, we want to talk about trigonometric equations. When we talk about equation, means we have an expression with an equal sign, which it has one variable. And the trigonometric equations are the equation that contain a trigonometric function or expression, like sine x or cosine x. And when they ask us to solve the trigonometric equation, means find the x, find the angle. Okay, so the solution for any trigonometric equations are finding the angles, because the x in any trigonometric function is an angle. And when you have an expression, you have an equation based on sine x or cosine x, and they ask you to solve this equation, it means that they're asking you to find x, which is an angle. Okay. When you have an equation, for example, what we learned so far about the trigonometry, it was that they ask us what's the sine of 30-degree angle, for example, or what is the cosine of 5 pi over 2, for example. They give us an angle and they ask us to find the sine of that angle or the cosine of that angle or the tangent, cotangent, and other trigonometric function. So the angle was given to you so far. Sometimes the angle was known angle like 30 degree, 60 degree, 45 degree. Sometimes was an unknown angle which you were supposed to use some trig identities and some technique to use the known angle to find the answer for unknown angles. For example, we learned the sine of alpha plus beta, which is the sum of two angle formula. In case, if they ask us what's the sine of 75 degree, I can use the 30 degree and 45 degree and the sine of 30 degree plus 45 degree by using the trig identity, find the sine of 75 degree. But when they ask us to solve an equation, this time, for example, we have a trig function which is equal to a number, a value, and they ask us to find the x. This time, the angle isn't given to us. So we have a value for that angle, and our job is finding an angle or all the angles that the sine of that angle, for example, is 1/2. So the sine of what angles is 1/2? 30 degree. Is it the only one solution? No, we have a lot of angles that their sine is 1/2, because you know that after one rotation, we can have as many rotation in every unit circle as well. So we can have infinitely many solutions. So that's why that maybe looking at this table can help us. This table, this picture actually, is given all the angles in one rotation of the unit circle. And the angles in degree, in radian, and also a coordinate point of that angle, which we know that always the x of this point is my cosine and the y is the sine. For example, if I ask you what's the sine of 30 degree, you say 1/2. What's the cosine of 30 degree, you say √3/2. So remember that the first angle is x, which is cosine. The second angle is the y, which is sine. So this picture gives you the sine and cosine of all of the angles in the first rotation. And if you have an angle in the second rotation or any rotation after the first rotation, you can find them by just using, by just removing the, each rotation and get back to the first rotation by just subtracting 360, because we know we have the same value. For example, if I have a 390 degree angle, which means I have this angle. it's more than one rotation, but I can easily remove the first rotation, the 360 degree, and my answer, it should be the same as the answer for 30 degree angle. So I recommend you have a print of this picture when you're solving equation and have it in front of yourself to look at this one, especially when they are asking you to solve equation and find solution in the first rotation from 0 to 2 pi. Let's look at an example. We want to solve this equation, the cosine of x equal to 1/2. Okay, when they ask me to solve this equation, that means they're asking me to find x, and I know x is an angle. That means they're asking me find an angle which the cosine of that angle is 1/2. So if I go back to the previous picture, the cosine of what angle is 1/2? Cosine is the x value. If you look at this picture, the x of each angle is 1/2. This angle and this one. So the angles are 60 degree and 300 degree. But when we are solving equation, we prefer to have all angles in radian. So instead of saying 60 degree and 300 degree, I say that the x can be pi over 3 or 5 pi over 3. Okay, so my angles can be pi over 3 and 5 pi over 3. If I want to find solution only from 0 to 2 pi, I say my answers are only these two answers. That's it. Pi over 3 and 5 pi over 3. But if they ask me to find all possible solution for this angle, it means that not only in the first rotation, find a solution that can also be in negative direction, find a solution that can also be in a second rotation, third rotation. So what do we do in that case? After finding the angles, the answers for the first rotation, 5 pi, 5 pi over 3 and pi over 3, we add or subtract them by 2k pi. What is 2k pi? 2k pi is just, k isn't just an integer. You can replace number for k. For example, if I replace k by 0, this whole thing goes to 0, so the answer is pi over 3. If you replace k by 1, your answers are pi over 3 plus 2 pi or pi over 3 minus 2 pi. And pi over 3 plus 2 pi means an angle in the second rotation. Pi over 3 minus 2 pi means an angle in the negative direction. If I replace the k by 2, I will get pi over 3 plus 4 pi and pi over 3 minus 4 pi. Again, I have angles in a negative direction and in a positive direction, but after, in the second rotation, in the third rotation. Okay, so anytime for the sine and cosine, you want to write all solution, make sure to add or subtract it by 2k pi. So find answers in the first rotation first, and then add or subtract them by 2k pi. And k can be any integer number like 0, -1, +1, +2, -2. But some of them may give you the same answer. So you don't need to repeat, the same answers. Okay, next example. We want to solve this equation. To solve this equation, I want to find the x, I want to find an angle, but this is a little complicated equation because I have no idea that what is the sine equal to or in this equation. So first step is just to isolate the sine, because before finding the x, we need to know what is the sine equal to, what is the cosine equal to. And you remember that whenever you're solving equation, your equation must only be based on one function. Everything must be based on sine or cosine or tangent. You cannot solve an equation that has a mix of sine, cosine, unless you change them, you replace some trig identity to make as a just one function. Okay, right now in this equation, I only have sine. So I don't have to be worried about that part to change the sine to cosine or cosine to sine or anything else. So I only need to isolate the sine because I need to know the sine is equal to what number, and based on that number, I find the x. So what do we do to isolate the sine? I need to move 3 sine x to the left side. So I subtract 3 sine x to the left side. And then when we subtract 3 sine x, we get 5 sine x minus 3 sine x, which is 2 sine x, which is equal to root 3. And if I divide both sides by 2, we get sine x, which is equal to root 3 over 2. Now, the function is isolated. The sine is isolated. Now it's time to find the x. I need to know that the sine of what angle is root 3 over 2. Let's look at that unicircle. Sine means the y value. The y value of which point or points is root 3 over 2. The y value. The y value of this point is root 3 over 2. Positive root 3 over 2. That's only these 2 points. So the x can be pi over 3 or 2 pi over 3. So the solution for this equation in the first rotation or from 0 to 2 pi are only pi over 3 and 2 pi over 3. But if I want to write all of the solutions, so I need to add or subtract 2 pi k or 2k pi to each of these solutions. So the solutions for these equations are pi over 3 plus or minus 2k pi, 2 pi over 3 plus or minus 2k pi. Let's look at another example. We want to solve this equation. Again, as I said, the equation must only have one function, and this equation has only sine function, so it's okay. And we only need to isolate the sine first. To isolate the sine, we need to move all of those terms that they have a sign in one side and the numbers to the other side. So I need to move 2 sine to the left by subtracting 2 sine x. And I need to move 1 to the right. So 4 sine x minus 2 sine x is just 2 sine x, which is equal to 1. Now if I divide both sides by 2, because I want the sine isolated, so the sine x must be equal to 1/2. After you isolate the sine and you got sine x equal to 1/2, now it's time to find the angle x. And I'm asking myself, okay, the sine of what angle is 1/2? Sine means y value. The y value, in which of these points the y value is 1/2, positive 1/2. This point, the y value is positive 1/2, and this point is also positive 1/2. So that means the answers are pi over 6 and 5 pi over 6. So the solution from 0 to 2 pi are only pi over 6 and 5 pi over 6. But all solutions, when I say all solutions, means all of the solution, not even in the first rotation, the second rotation, third rotation, negative directions, are pi over 6 plus or minus 2k pi and 5 pi over 6 plus or minus 2k pi. Next example, we want to solve this equation. This time the equation is based on the tangent. That's fine. We know that we must have only one function which we have. We just have tangent in this equation. So far, so good. And we need to find angles. We know that the tangent must be isolated. Again, it is isolated. We don't need to do anything to isolate the tangent because there is no number or sign in front of the tangent on the left side. So we just have to find the angle right now. And we need angles from 0 to 2 pi only. That means just angles, the solution in the first rotation. So to find angles, remember, even if you have the tangent of 2x, which is a double angle, when you are solving equation, you don't need to be worried about the double angle or half angle, or just keep it as is, okay? And just find answer. Think about an angle, not the double angle. 2x is just an angle, and the tangent of that angle must be root 3, okay? And the tangent of what angle is root 3? If you look at that unit circle, you may say, okay, I don't know the tangent, because on that unit circle, we don't have a tangent. We just have sine and cosine because we only have x and y, but we know that the tangent is sine over cosine. If you divide y by x, we can easily find tangent as well. But the tangent of what angle is root 3? The tangent of pi over 3, or 60 degrees root 3. Okay? Which means that my angle must be pi over 3, and my angle here is 2x. So instead of saying x is equal to pi over 3, this time you need to say 2x is equal to pi over 3. Okay? So 2x is equal to pi over 3. Just whatever angle you have in front of the tangent, just keep it instead of x, instead of just make your angle. And if you want to just write all solutions, you always have to add it. I told you, if you have sine and cosine, you always add by, for sine and cosine, you always add or subtract by 2k pi. Or instead of k, you can have any other, this letter, the 2n pi. You may see in some homework or some problems, it says 2n pi. That's exactly the same as 2k pi. But for tangent and cotangent, since the period of the tangent and cotangent is just pi, we just have to add or subtract by n pi or k pi. We put 2k pi and 2n pi for sine and cosine because the period of the sine cosines are 2 pi. So we say that 2x, or our angle, must be pi over 3 because the tangent of pi over 3 is root 3 plus n pi. Now, to find the x, you need to divide everything by 2. And if you divide all of them by 2, divide everything by 2, you get x equal pi over 6 plus n pi over 2. Okay, that's the general solution. If you replace n by numbers, you can get all of the solutions for this equation. But we only need the solution from 0 to 2 pi. Okay, so we just replace numbers for n until we get the answers from 0 to 2 pi, and that's it. If I replace the n by 0, I get pi over 6. That's an angle in the first rotation. Yeah, it's good. If I replace the n by 1, I get pi over 6 plus 1 pi over 2. Find the common denominator. We get 2 pi over 3. It still is an angle in the first rotation. Okay, we can have this as a solution as well. If we replace the n by 2, we get pi over 6 plus 2 pi over 2, which is pi. Pi plus pi over 6 is 7 pi over 6. And 7 pi over 6 is still in the first rotation. If we replace n by 3, we get 5 pi over 3 is still in the first rotation. So what happened if we replace n by 4? If we replace n by 4, we get pi over 6 plus 4 pi over 2, which is 2 pi. So pi over 6 plus 2 pi, and for sure, you don't even need to find the final answer, because for sure you know this is an angle more than 2 pi, because you are adding 2 pi by another angle, which is so you will get an answer after 2 pi, which is not in the first rotation. So you don't need to keep continuing replacing numbers for n, and you are done. You have 4 answers, 4 solutions for this equation from 0 to 2 pi, which you found all power 6, 2 power 3, 7 power 6, and 5 power 3. Next example. Solve this equation. Okay, to solve this equation, we need to check that we only have one function. Yes, we only have one trig function, and that's cosine. We need to check that the cosine is isolated, but it's not, so we need to isolate the cosine first. But we don't have only cosine, we have cosine square, so that's fine. We still need to isolate the cosine square, and after that find the cosine by taking a square root from the both sides. So to isolate this equation, we need to add 3 to the both sides and then divide by 4. Now we have cosine s square. We take a root from the both sides to find the cosine, and we get the cosine, which is equal to plus or minus root 3 over 2. Okay. So now we have two cases. We need to see the cosine of what angle is positive root 3 over 2 and the cosine of what angles is negative root 3 over 2. Let's look at the unit circle. Cosine is the x. So all of the points, all of the angles that the x value is positive and negative root 3 over 2. Positive root 3 over 2, negative root 3 over 2. Negative root 3 over 2, positive root 3 over 2. These are all of the possible solutions because the x value or the cosine of these angles are root 3 over 2. So the answers are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And the last example, we want to solve this equation. We need to make sure that the whole equation is based on only one trig function, which it is because they only have sine as the only trig function that we have is a sine. So we said that after making sure that we only have one function, we need to isolate the function. But isolating the function, if we don't have any powers, like the previous examples, or even if we have any powers of that function, we just have only one function. We just have a cosine square, that's it. But in this equation, I have a sine square and I also have a sine, both of them. So isolating the sine doesn't help me because I have two different terms with the sine x, and they are not even like terms that I can combine them together because one of them is sine x, one of them is sine square of x. So I cannot combine them together. But what can I do? When I look at this equation, it reminds me a quadratic equation. So if you remember the quadratic equations are equations are degree 2. Which we have a second degree term, we have a first degree term, and a number without any x. And that's exactly what we have here. We have a second degree term, first degree term, and a number that doesn't have any x or function or the variable. So what does it mean? It means I can use a quadratic formula because whenever I have a quadratic equation, I can use a quadratic formula or I can use factoring method to solve that quadratic equation. So we may be able to do this in this equation as well. But we know that for any quadratic equation, the other side must be equal to 0. But my equation is not equal to 0. We need to make it 0. So I'm going to make one side 0 first. So by subtracting 1 from the both sides, I get 2 sine squared minus sine x minus 1, which is equal to 0. Now I can find my a, b, and c. That's my a, that's my b, and that's my c. And I can use quadratic formula. If you remember, the quadratic formula for solving any quadratic equation was negative b plus or minus square root of b squared minus 4 ac divided by 2a. Or if you are able to factor, you can factor it out. Use X method to factor out. It's based on which method you feel more comfortable. So I want to use the quadratic formula right now. So I replace the b by -1, replace the b by -1, minus 4 times, replace the a by 2, replace the c by -1, divide by 2 times a, which is 2 times 2. And I know negative times a negative is +1. I need to simplify inside the radical. -1 squared, which is 1. And I need to multiply these three terms. -4 times 2 times -1. Negative times negative is positive. 4 times 2 times 1 is 8. And 1 plus 8 is just 9. Divide by 2 times 2, which is 4. And the square root of 9 is 3. So we have 1 plus or minus 3 over 4. So we have two solutions, one with the plus, one with the minus. The 1 plus 3 is 4. 4 divided by 4 is 1. One minus 3 is -2 divided by 4 is -1/2. And these are my two solutions. But these are not my x, because the whole equation was not based on x. The variable in my equation was sine x. The sine x had a second degree. The sine x had a first degree. So instead of putting x for the solution, we have to put sine x. So when I say the answer is 1, that means the sine x must be equal to 1. When you say your second solution is -1/2, it means the sine x is -1/2, not only x. Now we have more steps because I need to find x. Right now, I have found sine x. I isolated the sine x. Now it's time to find the x. So to find the x, I need to figure out what angle the sine is 1. The sine of what angle is 1? Yes, it's, if you remember the unit circle, the sine is the y value, and the 1 is over here, and the angle over here is pi over 2. So the x must be equal to pi over 2, just in the first rotation. And the sine of what angle is -1/2? If you look at this, sine is the y-axis. If you find -1/2 on the y-axis, and you graph a straight line crossing this point, you will get 2 points on the unit circle. And if you connect them to the origin, you will have two angles. That's my first angle with the sine of -1/2, and that's my next angle, which the sine is -1/2. Or we can have another way of looking to this equation instead. Instead of looking in these two angles, you know that 1/2 is the sine of pi over 6. When you have -1/2, you can say that's the same as the sine of -pi over 6, because you know sine is an odd function. If you keep the angle negative, that negative can be out and it still is there. So you can rewrite it as a sine of -pi over 6. So the x can be equal to -pi over 6. Now to find all solution, I need to add or subtract by 2k pi because 2 pi is the period of the sine function. And if you replace number for k, replace k by 0, by 1, by 2, you can find all possible solution in the first rotation. And you can also find the two angles that I told you over here. Okay?